What's happening, dogs? Mr. Allen here. Going to graph a couple quartic functions in this video, but we're going to do so using our parent function and transformations. And these functions are written in a rather interesting way. In fact, they use function notation on the right-hand side. So what does that mean? Well, I'm just going to apply my 1/2 outside of the function and the +2 on the inside. So let's rewrite this thing and then kind of figure out what the heck's going on here. So this would be x plus 2 all raised to the 4th power. Okay, so this would be your normal way of seeing it, but I've seen on some multiple choice tests, standardized tests, they'll just say, like, what are the transformations that give you g of x? Well, on the outside, I have a 1/2, so it's a vertical compression by 1/2. On the inside, we have a +2, so that's left 2. And we can rewrite our actual function from this. Sometimes they'll ask you to do that, whatever it may be. But let's write down those transformations now. We said a vertical compression, so vertical compression by 1/2, and then we have left 2. Remember, it's opposite on the inside there. And I'm going to use these transformations to help me graph it along with this lovely T-chart that I also provided prior to making this video. So let's set up a T-chart. Well, starts with a T. Then I've got x, and we have g of x. Now, there's different ways of doing this, but I actually like doing this little sort of a little side note, if you will, or somebody call it like a point rule. I actually got this from Mr. Ernst. Shout out Mr. Ernst. I'm saying that in every one of these videos I do right now. What's going to affect my x values? Well, the left 2 is going to affect the x value, not the vertical compression, right? Now, what happens on my graph when I go to the left 2? Well, if my value is at 0, I'd go to the left 2. I'd be at -2. I'd subtract 2. So I'm just going to write down here x minus 2, right? It's not what I see here. I'm translating this into, like, what it's going to look like on my graph, on my T-chart. We got to think opposite here in there with my transformations. Now I'm putting it into normal math. I know it's like a little weird. It could be easy to mix up, so be careful. So I take these values now, my -2, and I subtract 2. That point's going to be at -4. And if I take -1 and I subtract 2, I'm going to be at -3. 0 will put me at -2. 1 will put me at -1. And 2 will put me at 0. I'm subtracting 2 from all 5 of these values that I have in the parent function's T-chart. But how about my y values, my output? Well, that's a vertical compression by 1/2. In other words, I'm multiplying all my y values by 1/2. So what's 16 times 1/2? It's 8. What's 1 times 1/2? 1/2, or 0.5. 0 times 1/2 is 0. Then I got 1/2. And then I have 8 once again. And now I have all these ordered pairs already done for me, which is kind of nice. I find that easier than me, like, on the graph. I'm like, okay, I'm going to shift this way, shrink it, shift this way, shrink it. It's easy to mix things up, especially if there's a handful of transformations, especially if there's a couple of the transformations on your x value or both on your y value. Then it gets really tricky. So let's just plot these. -4, +8. Notice that we do have the scaling of our x and y axes differently. Axes differently. So that's why this one's by 1s, this guy's by 2s. The quartic functions get real tall, real fast. Something that I never experienced in my life, I'm sure. Anyways, we got -3, 1/2, so we're somewhere real close down right there. Then we have -2, 0, 1, 1/2, and then 0, 8. And now I can connect these. It gets pretty close to being flat for these quartics. Never gets flat, but it gets real close to it. Boom. Lovely. And that is g of x. Always label your graphs. Nice. It's beautiful. It's gorgeous. It's gorgeous. All right. Next one, h of x in green. Let's rewrite this, right, like we did before. H of x equals negative, and then it's 1/2 on the inside here. That does make a difference, right, because it's raised to the 4th power, plus 6 on the outside. Okay. So let's write down our transformations. What's that? What's the negative do? It's a vertical reflection. Vertical reflection. What's the 1/2 do on the inside? That is a horizontal. Is it a stretch or compression? If I flip it, it's 2. So it's a horizontal stretch by 2. And then B2 by 2. And then up 6 for the outside one. Up 6, right? Hopefully this stuff doesn't get too much in the way here. T-chart time. X and then h of x. So for my little point rule thing that we talked about, what's affecting my x values here? The vertical reflection, that affects the y. Horizontal stretch by 2, that affects the x's, right? That's going to pull this way. And up 6, that's for the y. So for the horizontal stretch by 2, I will multiply all my x values by 2. And for the other two, the vertical reflection, it's a negative, and then up 6, so negative y plus 6. Cool? Let's fill them in. So all my x values get doubled, so negative 4, negative 2, 0, 2, and 4. And then all my y values, it's going to be negative 16 plus 6 is negative 10. Negative 1 plus 6 is 5. 0, negative 0 plus 6 is 6. 1, negative 1 plus 6 is 5. Negative 16 plus 6 is 10. Nice. And with quartic functions, you should see that symmetry there, right? Okay, it's in green. Let's plot them. Oh boy. Negative 4, negative 10. Oh, we're in the clear. All right, awesome. Cool. Negative 2, negative 5. Look at that. 0. Wait, did I put negative 5? Positive 5. Whoops. Whoops. Positive 5. Still in the clear. Negative 2, positive 5. 0, 6. Then we have positive 2, positive 5. And then 4. That should be negative 10. Oh my goodness. Negative 10. 4, negative 10. Nice. Okay. So visually this should look like it has been flipped and shifted up and stretched out this way, right? It should be wider, should be shifted up, and it should be upside down. And it appears that this is, going to look that way. Nice. Got a little wobbly right in there, but overall pretty solid, right? It does get a little bit flatter in here, more so than like a quadratic. And then if you go to the degree of 6, it's even flatter near that vertex. But don't forget to label it. H of x. Nice. Wonderful. Fantastic, dude. Almost made a couple little mistakes there. Almost read that negative 10 there. Put a negative 5 for whatever reason. I don't even know what I was thinking. All right. There you go, guys. So hopefully that little point rule helps there. Throw some little notes off to the side as you're working through your t-charts to plot these things. But there we go. If you have any questions, pop them in the comments. Otherwise, have a great day, guys. Thanks for watching.